Today we have Pranav. He's a standard 8 student
Yes.
doing some amazing work on robotics that he'll talk about. We have Pranav's parents here as well. So I'll let Sanjeeva talk about, briefly about Pranav and the kind of work he does and introduce him.
First of all, good morning, everyone. It's a privilege to come here. My name is Sanjeeva, father of Pranav Kumar. Yeah, I work as a systems engineer at Raytheon. We manufacture jet engines. I work as a business scientist. This gave us the opportunity to come here, and I also work at Collins, right across the airport road. So this is briefly about me, but I want to talk about Pranav. Pranav has been showing interest, especially in robotics, and his passion is mainly on building products that are more sustainable, and as well as based on, he wants to build products that are useful for society at an affordable price. So his passion is always create something new that is affordable. And one of the things that I have noticed him is he's very persistent with the problem. So there are many instances where it didn't work like for weeks. Even after 5 weeks, it was ringing in his mind, and then he comes back with his an idea and builds the finished product from end to end. And he also makes elevator pitches. He talks about his journey of the product building in 3 minutes, and I post that as a social post. And he's been a 2-time World Robotic Olympiad champion. Just last month ago, we were in Singapore. The competition was about future of robots. Just the topic was so relevant to the current things that are ongoing with AI. So future of robots was also interest to me as much as he has interest to attend the conference. I wanted to go and see what is happening across the world. And there were 14,000 participants, 600 teams, and he contested in Future Innovators. There were 200 teams across the world. And I'm happy to announce that he got 7th place in the world. So that is he will present it more details about it, but that is what and I will leave something to talk to him as well. So I'm also accompanied. I'm happy for giving this opportunity to Rashmi and my wife as well. So it was really I was eagerly looking for meeting all of you and seeing the office as well. So that's it. I think I'll pass it on.
Thank you. Thanks a lot for the intro. For those who don't know, Pranav is Rashmi's nephew. So yeah, with that, I hand it over to you, Pranav.
Okay. So as you all heard, that's a quick introduction of who I am. So my name is Pranav. I'm 13 years old, and I've participated in a lot of projects and robotics interests. And this year and last year, I participated in WRO, World Robotics Olympiad, a robotics competition where I placed 5th last year and 7th this year, and I'm going to be very excited to show you more. So I will start. So I'm sure all of you know food is a very important part of our daily lives. We can't really live without it, right? We use it in everything, whether it be walking to school, working on our laptops, or just going to the grocery store. We need food for the energy and for our day-to-day lives. But food has a problem. Farming. Farming is very inefficient. It also is very inefficient. So it uses things like chemicals and fertilizers, which are known to leach into water sources, as well as damage soil. And this is a problem because this can cause diseases and whatnot, right? When we consume the food ourselves. So solution towards this was microfarming. Microfarming is essentially a farming technique that uses a small plot of land rather than hundreds of acres in a very efficient manner. So rather than using continuous fertilizers to kind of fix the soil or gives back those nutrients that we need. It uses crop rotations, a technique where instead of putting back nutrients, you would take a plant, like say potatoes. Potatoes require a lot of phosphorus. So soil has three main components: nitrogen, phosphorus, and potassium. Each plant requires all of these in a certain amount, but sometimes plants prefer one over the other. So phosphorus, potatoes love those, but kale, for example, doesn't. It doesn't really use this. So rather than putting kale in an area where there's an abundance of phosphorus, we go and we try to detect these areas where there's phosphorus, to put potatoes, sorry, if I can drink some water. This gives us a more efficient yield and maximizes our crop growth, as well as with things like water. So as we all know, farming requires a lot of water, but microfarming is an efficient way to use less of it. So an issue that we've seen is when we have uneven land and we plant our seeds, when we rain or when we water our crops, the seeds tend to drift with the water and pile up in areas like puddles or pools. And eventually they set their roots down here and grow. This is an issue because when they do grow, they use all the nutrients in that small area, and it runs out very quickly, leading to poor crop yields, as well as sometimes the plant just completely dying out. So, and the solution that we came up with was TerraSoils. So TerraSoils was a compact 3D printed robot that came at an affordable scale. So the way it worked is we used a bucket towards the front of the robot. As you can see, international iteration, you can use the pointer over here. And in our international iteration, it's just under there to pick up and put soil in areas where it's either low or high. This, we continuously repeated this process until the soil was even, right? But during this time, we also realized that nutrients, right? The nutrients problem. So to fix this, we use something called an NPK tester. So essentially, it has three prongs. These prongs can detect each nutrient, so nitrogen, phosphorus, or potassium. Using this, we would map the entire area of the microfarm, as well as level it out for even water distribution. When we had this, we could easily create like a digital map, you could say, of the entire land. And using this, farmers could efficiently plant their crops. For example, farmers would never be able to know where that phosphorus is normally. But with our robot, it could easily be dispatched, map out the entire area, and know where these nutrients are. Using this, farmers can create a more efficient layout to their farms, increasing crop yield. And as you can see in this one, so we had multiple iterations, 3 for matter of fact. So regionals one, it's not being displayed here, but it was very rough. So when we went to nationals in Canada, we refined our robot. We concased it, we used a bucket loader, and we as well had a piston underneath here that could detect the soil. But for our international version, when we won first place in Canada, we decided to fully 3D print it, but still use Lego parts. As you can see, we have motors and we have some Lego parts up here. But this allowed us to create a robot that was yet small, but very efficient and cost effective. So it would come about less than $400 or less. And this would make it accessible to people who really need it, like small scale farmers or communities that don't have much to give. So this is kind of like a summary of the entire robot if you'd like to read. So the way we leveled the soil was we used a light sensor up here. The light sensor, as well as a laser on the side of the farm, would be able to tell. So say the robot went down, the laser on the side of the farm would hit one of these 3 points in the middle, where we could say it's level, or below or on top. So when the robot went down, it would hit the top sensor, telling it that, okay, there's a ditch here. And we would take this into account and keep it with us. And we'd do this for the entire farm, giving us that map, right? So we call that the LDR system over here, light dependent resistor. That's how we leveled the soil, as well as we use the piston on the back, along with the nitrogen, phosphorus, and potassium sensor to test and give us this map. And this is just my certificate, and if you'd like to read, I'll move on to the next slide. Okay, so this year, yet again, I participated in WRO with a project called Electrostatics. So this year we had the theme of future of robots. And within this theme, we have three separate subcategories. So we had AI in daily living, AI improving in space, and we had AI in autonomous. So what was the name? Yeah, let me just think about it. AI in automotive, so moving from place to place. So this year, when me and my team were going through and we were looking at these topics, we noticed a problem. So as we know, now with the advancements of AI, we can go to places like the moon and beyond, where we originally couldn't because we had these limitations. But now, when we can go to places like the moon and whatnot, we still encounter a problem, lunar dust. So when we went to the moon, an issue that we commonly saw was lunar dust. So think of it as very sharp, kind of like sandpaper, but it sticks to everything. So because of this, when rovers were to rove or move across the surface, lunar dust would get kicked up and stick to all sorts of places, whether it be solar panels. This would reduce the production of energy for itself, or joints like over here, or wheelbarrows. This is a problem because in this photo, you can see China's U2. It was a rover that failed due to the fact that lunar dust got in between its joints and it couldn't bring its solar panels in, leaving it exposed to the harsh conditions of the lunar surface. And this unfortunately caused it to fail. Over here. But multiple existing solutions were created, two of which are heavily implemented. Electrodynamic dust shield, or EDS, kind of creates a wave of electricity above delicate components to lift up and repel the dust, but has a very small range, so has to be implemented across the entire rover. Or lunar nonstick coatings, which work for a few months, but wear out very quickly, making it ineffective. So our team decided to look into these and find a solution to this problem. So we decided that we would use a 6DOF robotic arm to solve this problem. So essentially, we know that lunar dust sticks to everything, whether it be the wheels, solar panels, or whatnot. So to reach these parts, EDS or lunar nonstick coatings would have to be applied across the entire thing, making it very costly. To fix this, we decided to use a robotic arm to reach every part of the rover, allowing us to reduce the amount of EDS required. So to remove the dust, we decided to go with a hybrid approach. Rather than just using one system like EDS to push the dust away, we decided to reverse it, pulling dust in, as well as use a physical approach using a microfiber cloth to remove of the dust. This ensured that we could accurately and effectively remove of the dust. So we had multiple iterations yet again. Our regionals prototype kind of being rough, where we used a metal skeleton. It was completely exposed and we had just mounted it on top of a rover. And this one was third place, letting us move on to our provincials, where we decided to encase this. So we used 3D printing technology to cover all sorts of wires. We bundled them and we used an Arduino Rev 3 to power our model and move it. But this year, for our internationals one, we yet again had to use 3D printing technology. We actually went through multiple iterations. So our first iteration kind of failed because we had issues where the infill or the internal material within the structure would break or couldn't support the weight. As you can see over here, this is our joint where our motors would connect. It completely tore out and broke. As well as we had electrical issues where our wiring would keep interfering with other parts and would cause problems. Robot would jitter, the robot would fall, or completely just not work. So we created a solution sheet and as well as a sensors and tool sheet so that you could learn and understand what we used. So in this, 3D printer technology, as well as an Arduino and servo motors we use. The reason we use servo motors across anything else is because servos allow us to know where we are. Essentially, normal motors just run continuously, so we never really can control them properly. But servo motors allow us to know where we are or know the angle of the shaft. With this, we can accurately control our robot. And then two other systems that we used were soldering grippers. So this helped us during the electrical process, as well as a ball bearing. So when our arm would rotate, giving us a 360 degrees, it had an issue where it would keep scraping against the base. And it caused too much friction and the motor just couldn't move the arm. So to fix this, we used a ball bearing setup which reduced this friction as well as bared the weight of the arm, allowing us to have a full smooth 360 degrees of rotation. So during the process of building this robot, we saw that I needed a bit more space in my house and my room wasn't really working. So in my garage, I built a small workshop to meet my needs. So in this photo, you can see I have 2 workbenches over here. I built that. We've got the wood cut and everything. So this proved to be very helpful during the process of building the arm. If you can see in this photo, we have some parts of the arm, as well as if you notice, there are 2 aquariums in both photos, up here and here. So these are both my pastimes that I enjoy a lot. It is called aquascaping. So aquascaping is it's a kind of like an art where you use natural materials, whether it be stones, wood, or aquatic plants, to create self-sustaining ecosystems. So I really enjoy this because it helps with a lot of stuff. And in this photo, there are 2 tanks. So I am actually a champion in the aquascaping category for my age, junior, where this year at the Canadian Aquatic Expo, there was a competition and I won first place with this tank. So in the process of learning aquascaping or doing everything, I noticed problems as well. So solution to this was developing an affordable product line. So I started a business around these items. So I noticed that it was very expensive for people to get into the hobby, whether it be for parts or it's very complex too. They couldn't really know what they needed and what they didn't. So I could decide to create an affordable product line of these items. So as you can see in this photo, I created a tank setup where it would come with everything you need, whether it be the light, soil, plants, or filter, at an affordable scale. So it would ship to your door anywhere you are for less than $200, as well as a canister filter, which is a filtration setup that sits outside of the tank, giving you more space, but is very efficient, so it would clean the water properly. Another business that I enjoyed was 3D printing. So 3D printing is very important to me because I use it in a lot of my projects, whether it be for robotics or whether it just be organizing my drawers in my workshop or whatnot. I decided to help people in my community. And one way I did this was starting an entrepreneurship market at my school. So during May, I organized this market where students across the entire school could bring in their businesses or give their ideas out in a group environment. So essentially, within the gym, we set up tables and booths where you could bring in whatever you want to display or to sell, and you could sell them at an affordable rate to everyone. I decided to bring in my 3D printer and set up a print-on-demand shop. So essentially, what this is someone would come in and say, I would like to 3D print this. Essentially, I would take that model, put it into my software, and see how long it would take me to 3D print, as well as how much material I would use. Using this, I would then charge a certain amount and print it in front of them. As you can see in this photo, I am using my 3D printer to print some name tags, which were an absolute hit over there. And over here, these are some of my awards. So this year, I won first place at my nationals and third place at my regionals. So those are my awards. This is the Earth Allies theme for last year, WRO 2024. And this is the theme for this year, Future of Robots 2025. Thank you for listening. If you have any questions, please go ahead. Thank you.
I think very interesting. Well done. I have a question about the first project that you showed, right?
TerraSoils?
Yes. So what I wonder is actually, wouldn't you get the same effect just by mixing the soil with plowing and tractor and so on, right? Instead of doing these things, right? So it might be more effective to just make the soil more uniform rather than doing patchwork on each part. Yeah.
That is a good idea, but I think the main reason you can't really till it is I think because microfarming is a place where it could be used on small plots of land, usually your backyard, your rooftop, or somewhere like that. So tilling can sometimes be difficult. So and then autonomizing it would just be much easier for people who don't really know as much, right? So if you're just on a workshop or on a rooftop of your apartment, right? Having the robot, it would take time, but the robot would eventually slowly even it out. But yes, that is possible. Tilling the soil would give a similar result.
Great work. Really good job. So I'm more interested around the WRO competition.
Mhm.
How is it orchestrated? What are the timelines? I have a brother around your age, and he's also into robotics, but hasn't really competed there. So
Um,
just want to know how would you approach like the next year's competition and stuff?
So the way we approached it really is so every year we get a certain topic. This year it was future of robots, and within this we take time to research the thing. So it took us about a month to 2 months to finally settle down on our issue and know what solution we needed. So we usually just go through each and every one, researching problems that's been seen here. We usually lay them out and try and find the one that best suits our goals or the one that we can solve easiest within these.
Got it.
I can add that. Basically, um, the the WRO actually was started in Singapore in 2004. So it was so coincident that this year again it came back to Singapore. So every year this organization gives a topic based on UN research. So UN gives up like some topics that are need of the society. It's not the topic of the society, it is need of the society is driven by the topic. So last year topic was future of robots. So every country, like whoever participates, they actually have a competition at the local level, meaning in a area wherever you are. And then it is competed at the national level. And one topic, there are 4 categories in World Robotics. One is future innovators, one is robo mission, future engineers, and then there is another category I don't recollect. So the intention is to motivate the kids to come up their innovative idea. Generally, like in a company setting, if we have to produce this kind of concept, it will take years, like it not at least a minimum year. But here with this opportunity for the kids, like because they are not they don't have any limitations, but they have to come up with a proof of concept. So it is very efficient, and all the topics are reviewed by the international panel, and 50 of them are selected across the world, and they send back this for the UN to review. There is a committee that reviews all these projects, and they allocate the funds accordingly. So the like last week topic was very interesting. So do you know why future of robots is asked last year? Any guesses? Any guesses? Like why future of robots was asked? Because technically speaking, robots industrialization happened from 1960 to 2000. The maximum that can be done by any robot is already achieved in every sector. But still, the topic was future of robot. Any guesses? Okay, I'll tell. The future of robots, in my view, is because with the advent of AI, it is like a rebirth for the robots. But it was not just for a rebirth of with the scale of with the there is a lot of industry, society, and government institution partnerships that are more reachable now than in the past. That is another reason. And the other thing is future of robots is not just future of robots, because as he said, we want to colonize lunar spaces, right? So if we want to colonize lunar spaces, they can send you and me, but we cannot sustain the environment, right? So they want to send robots. But if they want to send robots, in the past, robots are programmed to do some task, but they won't behave like us. So now with the advent of scale of AI and like technologies like Omniverse and Cosmos from NVIDIA, you have the opportunity of enabling these robots to behave like us. which is we call artificial general intelligence. General being, they are expecting the robots to behave like us. So when we want to send robots there, they are expected to perform operations like us. So, and to summarize the future of robots, it's not just for robots, it's future of us. They want to know how we would behave in the, like we want to know exactly what will be our future. So that's the reason, I guess, the future of robots was given as the topic. So yeah, it's a very competitive. And do you guys know who wins maximum, like which country wins the maximum? Huh? Any guesses? Yes, good guess, but any? Which one? Korea. Korea, another good guess. I'm really surprised when I went there. Actually, Malaysia wins in every division. I was so shell shocked because even India had a very interesting project. Actually, it is very close to Microsoft, I guess, because the team that represented India was recognized. They were they met Narendra Modi, and they were recognized by the entire government of India, but they still couldn't win the first prize. But they are actually from Bangalore. So when I asked them, the Malaysian team people, there is an enormous competition. In each division, there are around 2,500 teams compete to get one spot. So obviously they are the toppers. Yeah. Okay. So I think if you have any other questions, I can tell.
So my question to you is like, what I feel is like there are so many things to learn in these projects that you were working on, right? I mean, mechanical engineering, computer science, and whatnot. So which AI tools are you using for learning, and how are you using them?
So me personally, we really use something. I use Fusion 360 to design my parts. So something that we've been recently able to do with the advantage of AI within these sort of softwares is when we design a component, right? We have a lot of extra material that we sometimes don't need, but we don't know that ourselves. So using a software within Fusion 360, I forgot the exact name, it reviews the part, it checks the part, and it finds weaknesses. It'll tell you these weaknesses as well as it'll strengthen them, and then it will remove material that we don't need. So if a part that once weighed 500 grams was there, but it was still weak at the joint, Fusion 360 would review this. It would find the areas that it was weakest, ask you to reinforce it, and remove areas that we don't need. So I actually use these on our T-joints. So our robotic arm is made of 6 of them, for a matter of fact. Over here, yes. So within this, you can see these joints. These are T's, so they have one area where you can connect to the next joint, and then one area that has a servo for power. So we used this and we paired them up as well as separated them with 3D printed spacers to build our arm. But in this model, at first, each joint weighed about 600 grams, which was too heavy, and it still broke even with multiple reinforcements. So we used Fusion software to go through one by one, checking parts, reducing the weight, as well as strengthening areas like in this bridge over here, which bared a lot of the force and torque of the motors. We strengthened these parts and were able to reduce the weight from 700 grams to just about 200.
Thanks. First of all, thank you so much for the amazing presentation that you gave. Very inspiring, Pranav.
Thank you.
I'd met one Pranav 2 years back, and I was inspired by him, but he was grade 10th student, and today I'm further double inspired listening to your presentation. I think loved your garage that you talked about, and I first of all would like to invite to Microsoft Garage to see the stuff that we have. Reinforcement for me when I looked at the stuff that you've done with 3D printing. So definitely, great use cases, and couldn't agree more with you embodied AI is the future. There's a lot of work happening on embodied AI with the robotics, and I think it's already doing wonders today in industries, and adoption rate is pretty high. So, encourage you to explore that part of the world as well. There's a lot more that can be done. I like two things. One, of course, we talked about the affordability in your solution.
Yes.
I'm so used to listening to that when I'm sitting in this office, MSRI, because researchers talks about it all the time. And I like the way you have approached your project solution. So really like that. And the most important thing, I liked your learning that you shared, how it failed and how you kind of improved on that, and the analysis that you did. I think that is something is a great takeaway for me, because experimentation and growth mindset is something which we practice, and you doing at this age is super inspiring. I wish you all the best. You have a great future, my friend, and keep hacking such solutions and make a difference in this world. Thank you so much, and do welcome and visit our garage as well here.
Thank you so much.
Hey, really amazing work. So Pranav, when you use these, vehicles to roam around, right, and so on, so are you actually training these for navigation, the models or something, or you're programmatically
Like
implementing
for
these?
moving the rover, or like
Yeah.
for the rover really isn't part of our solution. Our solution's more or less a system to protect rovers against the harms of lunar dust, because it has issues where it sticks to everything and sands down on these parts. So it's continuously sanding down. It's also conductive, so it's been known to create short circuits between parts as well. So that's really the gist of our solution. The rover is essentially what we're trying to protect, though, not
Or the
part.
robotic arm, right?
Yes.
So that moves autonomously, and or is it remote controlled, or?
It moves right now. It moves mostly with a hard code. This allows us to give a program that we can show our judges. But we do have an autonomous part of it, where if you were to train it on something, so if you were, for example, we had chosen the color green because it was showing brightest against your background, but it would track this color or move to wherever it is. Once it stops, it will move towards it and use its system. So it'll use the brush head to physically scrub it off, or use the reverse EDS to push away on the dust.
Cool. Yeah, thanks.
So probably you should show the video,
Yes, I think I do have a video.
the video of that.
So as you can see, each joint moves individually. It's independently powered. And right now in this one, we're just showing it move the brush head. It's kind of hard to see in the video, but the brush head moves continuously back and forth, and it uses an electromagnet to pick up the dust. If anyone has questions, feel free to ask.
Thanks. Questions here online? All right. If not, we'll thank Pranav for this amazing talk.